Hello everybody. Today I'm going to explain and demonstrate what is white noise. Well, the term white noise has been derived from white light, which is nothing but a combination of different colors of light. Similarly, white noise is also a combination of different frequencies of sound. Moreover, it's a combination of all the audible frequencies of sound, meaning it's a combination of 20 Hz to 20 kHz signals of sound. So now let's look at the time trace of a white noise signal, meaning how the white noise will look when plotted in real time. So the x-axis represents the time signal, the y-axis represents the amplitude. So this is a white noise signal in real time. So the white noise signal is a discrete signal with random, variables of amplitude. So if we consider a small chunk of the signal and you look at the distribution of amplitude, you will get a normal distribution, and the normal distribution is also called Gaussian distribution. Now since the white noise signal follows a normal or Gaussian distribution, it is also called as Gaussian noise or Gaussian white noise. Alright, so this is in the time domain. Now let's perform a mathematical operation to get the frequency domain. So to get the frequency domain, we perform an analysis called fast Fourier transform. So after you perform the analysis, you will get the same white noise represented over frequency. So before we look into this, let's look at a small relationship of power spectral density versus frequency. So the power spectral density is inversely proportional to 1 over the frequency power beta. Beta is 0 for white noise. It's different for different colors of noise, but for white noise it's 0. And if you plug in that, the power spectral density is just proportional to 1, or it's a constant. So as you can see here, the power spectral density versus frequency is just flat. So this means that the power spectral density is constant over the entire frequency range, and it's also constant in each band. Let's say if you consider the lower bands 100 and 200 Hertz, so the bandwidth is 100 Hertz, and if you consider very high frequency band here, 1000 like 5000 and 5100 Hertz, the power spectral density is same no matter where you are in the frequency spectrum. So it's a constant over the entire frequency range. Alright, so the white noise also occurs naturally. It can be produced electronically, but it also occurs naturally in waterfalls, rainfall. And white noise has different applications. The most common application is speech privacy, which is achieved by sound masking. So the white noise becomes the masker here. It starts to mask all the other frequencies, all the other sound, thus keeping the unwanted sound out. So these are the applications of white noise, and yes, it is also used in the treatment of tinnitus, where you feel an artificial ringing in the ears even though there is no sound present. So this is used in the treatment of tinnitus, and also it is used in getting sleep. Alright, so this is white noise. Now I'm gonna demonstrate how white noise sounds using an app. Hello there, this is the multi-tone generator app, so it can generate white noise. So I'm going to play the white noise and you can have a feel of how it sounds like. Here we go. So this is how white noise sounds like. I'll increase the volume. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.